Happy Monday, Mustangs! This is going to be the Math Spiral review for April 24th in our Phase 2 of Distance Learning. Let's go ahead and get started on these 6 problems. So the first one, William bought 3 new video games and 4 used video games for $65. Each new video game cost $15. The used video games were all the same price. What is the cost for one used video game? So as always, we need to address the question. So our ultimate question or our ultimate answer needs to be, what is the cost for one used video game? When I go back and reread, I see some really important information in that first sentence. He bought 3 new video games, and then he also bought 4 used video games, and altogether that total was $65. Also, I need to note that each new video game costs $15. So I'm going to go ahead and start there. I'm going to go ahead and start by drawing a picture. So he bought 3 new video games. So I'm going to go ahead and draw 3 squares to show those are the 3 new ones. And each of the 3 new video games costs $15. So I'm going to go ahead and write $15 in each one. What I need to figure out is how much the used video games cost, and there were 4 of those. So I'm just going to draw 4 blank squares, but I'm not going to put anything in them yet because I am not sure of those answers. So to start with solving this problem, we're going to start with our total of $65, meaning all 7 of these games together cost a total of $65. And I'm going to take away what I know for sure he spent. So I know for sure that he had to spend $15 on each of the new ones. So I'm going to go ahead and add those 3 15s together for a total of $45. So he spent $45 on just the new video games alone. And I'm going to go ahead and subtract those 2. So 5 minus 5 is 0, and 6 minus 4 is 2. So what I have left over, this 20, represents my new total, which means these 4 used video games all together had to add up to equal $20. So what I'm going to do to figure this problem out is I'm going to take this $20 and divide it by the number of video games, which is 1, 2, 3, 4. So 20 divided by 4 is going to be 5. Which gives us the answer. So all these used video games each cost $5. And with our question being, what is the cost for one used video game? One used video game is going to cost us $5. Okay. The next problem, a classroom teacher is looking for a large rug for her classroom library corner. The rug must be between 60 and 70 square feet. The rug must be less than 10 feet long. Draw a model. So while reading this problem, some things stepped out to me. The rug must be between 60 and 70 square feet. Now, this term, when I see this square feet, that means that they must be looking for the area of a rug, meaning that the area has to be between, or the answer to the area has to be between 60 and 70. And if we remember, area equals length times width. It also must be less than 10 feet long. So any of the 2 numbers that I multiply together to get between 60 and 70 cannot be 10 or higher. Draw a model. So I'm going to go ahead and I'm going to just draw in a rectangle here. So what this problem is stating is that the width and the length of this multiplied together have to be between 60 and 70. So whatever 2 numbers I choose, whatever times whatever, length times width, has to give me that answer between 60 and 70. So the first thing I can think of right away is that 8 times 8 gives me 64. So if I do a length of 8 and a width of 8, I'm going to get a total of 64 square feet, which is one possible answer. Can you think of any other 2 numbers that when you multiply them together would give you between 60 and 70? That's going to be our next question. So one of the answers or possible answers could be 8 times 8. The other possible answer we could come up with would be 9 times 7 or a 9 by 7 foot area rug. Because 9 times 7, I'm going to draw it up here, 9 times 7 gives me 63, which means the area will be 63 square feet. Are there any others I'm missing? I will leave that up to you. Okay, Mustangs, the third problem, and one of the easier ones. Find the product of 15 and 12. Here's my key here. This word product means what? Yep, that's right. It is an answer to a multiplication problem, meaning that we have to multiply 15 and 12. So I'm going to go ahead, since I did not show my students the algorithm way, I'm going to go ahead and draw a box for that and show you how to do it with the area model. So if I go ahead and I make my rectangle or my boxes, and I'm going to go ahead and I'm going to make it into two different ones like this. And on one side, I'm going to have the 15. So I'm going to break it apart between 10 and 5. On the other side, I'm going to have 12. I'm going to break that apart between 10 and 2. I'm just breaking it down by place value in case you forgot. So the first one I'm going to multiply, I'm going to do 10 times 10, which is 100. And then I'm going to go and I'm going to move this 10 over, 10 times 2, which is 20. And my next box is I'm going to be 5 times bringing this 10 down, 5 times 10, which is 50. And my last box, which is going to be 5 times 2, so I'm going to bring this 2 down, 5 times 2, which is 10. My last step is to what, everyone? That's right, I know, I'm sorry, I can't hear you, it's old habits. We're going to go ahead and add up all these numbers. So I'm going to add up 100 plus 50 plus 20 plus 10 to find my total product. So my total product here, all the zeros in the one place, 5 plus 2 plus 1 is 8, and 1 plus nothing is 1. So 15 times 12 is going to give me a total answer of 180. Woo, flip. Okay. Halfway through, friends, select all the expressions that have a value of 20. This is the part that might trick some students. The value of 20 just means that the answer has to equal 20. So let's go ahead and take a look at this first problem. 350 divided by 5. Now I could do this the long division way, or I could pull out that this is 35 divided by 5 with this placeholder 0 at the end. So 35 divided by 5 is going to be 7 with that 0 at the end is 70. Because the answer, the quotient to this question is going to be 70, this is not going to work. The next one we're looking at is going to be 16 divided by 8 with a 0 at the end. 16 divided by 8 is 2 with our 0 at the end is 20. So this quotient is actually going to have a value of 20. So this one works for us. The next one is going to be, and this one's tricky, this messes a lot of students up. This next problem is not 2 divided by 4, but 20, oops, sorry, need the highlighter, but 20 divided by 4. That's the key here, and that's going to give you a completely different answer. So 20 divided by 4 with a placeholder 0 at the end. 20 divided by 4 is 5 with a placeholder 0 for 50, so this will not be a viable quotient for our question. And last but not least, we have 120 divided by 6 or 12 divided by 6 with a placeholder 0. So 12 divided by 6 is 2 with the 0 at the end is 20. So B and D are both answers to this question of the value of 20. Okay, draw two fractions that are equivalent to 4/8. You could do a couple of different ones on this. Some of you may realize right away that 4/8 is equal to 1/2. So one of the ways to draw this would be to show 4/8 first. I'm going to go ahead and fill those in. So if I'm looking at this problem right away, that I can see 4/2 is exactly half. So if I can, I'm going to just go ahead and I'm going to erase this line, and this line, as well as this line, and this line, to show that this is an equivalent fraction of 1/2, or 4/8 is equal to 1/2. That's one way of doing it. You could have also done it where you made the number slightly bigger, and for this I'm going to make a little bit bigger of a rectangle. So again, I'm going to cut it up into 8 pieces. Shade in that 4 out of 8. Oops. There we go. And in order to show this, I'm just going to go ahead and I'm going to break apart each square into 2. So I'm going to go ahead, I'm going to break this one into 2, and you can tell by the dotted line. Actually, let me do it in, let's do this one in orange. So if I add these lines and cut every single piece up into 2 more pieces, My new fraction for 4/8 is going to be 1, 2, 3, 4, 5, 6, 7, 8 total shaded. So I'm going to go ahead and add in 8 total shaded. 8 total shaded out of how many total? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So I'm going to have a total of 8 16ths, which is also equal to 4/8. What else can you come up with? These are not the only two that we can make. If you came up with a fancier one, when you turn in your packet, I'll check out that answer. And last but not least, this model represents the decimal 7/10. That is actually how you say this. And I know we haven't worked a lot on decimals, friends, but this 7/10 right here, that is actually how you pronounce 7/10. What fractions does 7/10 represent? So if I go over here really quickly, I'm going to give you a quick place value lesson. When we're remembering place value, we have the hundreds place, the tens place, the ones place. After the ones place comes that decimal that we've been talking about. And then we can also see that on this other side, we have tenths with the THS at the end. That's key there. Then we have hundreds with a THS at the end. That is also key. And I bet you can guess the last place value, which is, you guessed it, thousands, with a THS at the end for thousands. Now, what that means is if I have a number in the tens place, such as 4, that means my new number is going to be 0.4 or 4/10. And you actually say this number the same as you would say this one. Therefore, this 4/10 is the same as this 4/10. So keeping that in mind and going back to our problem here, this model represents the decimal 7/10. What fractions does 7/10 represent? Well, when we're looking at this problem, it is even actually drawn for you. I could just go ahead and count 1, 2, 3, 4, 5, 6, 7. So I could make that fraction of 7 shaded out of a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I could make it a total of 7/10. Keep it in mind that this 7/10 is literally the same thing as this 7/10. There are no difference in the way that you say it, only in the way that it's represented. If you wanted to get fancy with it, another way to write 7/10 would be simply to put 70 hundredths. Now, as long as you're putting those those zeros at the end, it's going to be the same thing either way. And that could be some of those, I see this S at the end of fractions. That could be two possible answers to how you model 7/10 in fraction form. All right, Mustangs, I hope this helped. Have a good start to your week.